Okay, you kindly put your answers in the chat. Okay, so we all know that. But when you take the data link layer, we have a two layer. I think ma'am have told yesterday, LLC, logic link layer, MAC, media access control layer. So we have a two layers in the data link layer itself, LLC layer and a MAC layer we used to say. Okay, but we all know that according to the OSI model, the down layer is physical layer and the upper layer is network layer. Okay. While we move on to this logical link layer, okay, logical link control layer and media access control layer. So while we see about this logical link control layer, all that Ethernet, that is wired LAN and wireless LAN, we have a two types. We are going to discuss. In the wired LAN, we are going to discuss about Ethernet only. Wireless LAN, we are going to discuss about IEEE 802.11. That is nothing but your Wi-Fi. Okay. And then the next one is Bluetooth. So wired LAN, Ethernet and wireless LAN, Wi-Fi and Bluetooth we are supposed to take. So this data link layer having LLC, that is logic link control layer, and another one is media access control layer. Okay. Now we will see the purpose of these two layers. Then we will move on to the wired LAN, that is Ethernet we will see. Okay. So logic link control layer or data link control. The name will be same one, LLC, or we used to say DLC. Okay, what it will handle now? It will handle the communication between the upper. I told you the data link layer, down layer is physical and upper layer is network layer, that we all know that. What this LLC will take care now, while we are seeing about the data link layer, it always do the flow control and the error control and all, we all know that. That flow control will be handled by the LLC sub layer. Data link layer, we have a two layers, LLC layer and MAC layer. In that particularly, the LLC layer will do the flow control. Okay. And MAC layer, it is mainly related to the hardware. Okay. Network, NIC. Did you know that? Network interfacing card. Okay. While we're doing with the physical layer, it will be used. So it have a two primary, data encapsulation and media access control. So that will be done by the MAC layer. Okay. In that, when you see that, what are these five purpose will be served by this very important PPT, flow control, framing, physical addressing, error control, access control. These are the five purpose which is served by the data link layer. Okay, and among that, the flow control alone will be taken by logical link control layer. The remaining framing, physical addressing, that the head and trail we are adding the data, adding the addressing, that physical addressing, error control mechanisms, access control, all will be taken by the media access control. And you all know that the media access control mainly related to the hardware, and the NIC, network interface card, will be responsible for that. So you have to understand that we have a two layers in the sub layers of data link is logical link and data link, logical link or data link control, and another one is MAC layer. So in that logical link control always take down the purpose of flow control. The MAC layer will take the remaining responsibility like framing. Already the unit starting itself we have taught you about the framing, error control mechanism we have done, and how to map the physical addressing. And while coming to the physical addressing, here while we are seeing IEEE, that is your Wi-Fi and Ethernet, we have a addressing frame from it. That we will follow and we will add the physical addressing. And then access control. The access control means we all know that transmitting medium access control, we will transmit through the radio frequency. So how we can access the data. So all this responsible will be served by the data link control, data link layer. And in the data link layer, we are dividing LLC and MAC. Okay, so in the data encapsulation, why we are seeing about that. So before transmission and framing disassembly, that is what it will do now. Whenever I receive the packets, I will check and I will append in sense, I will append the head and trail, and then I will send to the next layer. That data encapsulation will be done in the MAC layer, and among that it will have a framing. Framing I told you. IEEE 802.11 have a one framing structure, Bluetooth having one framing structure, and Ethernet having one framing structure. That framing will be, that framing on physical format will be done by the MAC layer, and then error control also will be done. For example, I want to do any cycle redundancy check, or I want to do any checksum algorithm. All that will be done by this MAC layer. Okay. So I think this all about the purpose of data link layer, and that is a logical link control layer and a medium access control. Actually, we used to say LLC only, LLC MAC, that only we used to say. So I think that is get over. Okay. Now, students, you just take down this one important topic. We are going to discuss about wired LAN and wireless LAN. So wired LAN, we are going to cover Ethernet. Wireless LAN, we are going to cover IEEE 802.11 and Bluetooth. Okay. In that, ma'am taught you about CSMA. Okay. CSMA CD also ma'am taught, and especially CSMA CA, we will go with wireless LAN. So that time I will explain you. But here we are going to discuss about two types: wired LAN, wireless LAN. Wired LAN, we are going to focus only on Ethernet. Wireless LAN, we are going to focus on Wi-Fi and Bluetooth. Is clear? Okay. Now you just see the Ethernet evolution. Okay, while we are seeing about the Ethernet evolution, it is standard Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. How they are classifying now, depending upon the speed: megabit per second, 100 megabit per second, 1 gigabit per second, 10 gigabit per second. So how we all know that this depends on the speed only. We are classifying standard, fast, gigabit, 10 gigabit Ethernet. Okay. So that's why we've seen that while we use the modem in 2010, 11 and all, we cannot able to use it in 2016, 17. Because of this evolution of the Ethernet, we are supposed to change the modem, even though you are using the same service provider. Because of this, speed of the internet have been done from the evolution, starts from 10 Mbps to now the 10 Gbps, because the Ethernet design have done and evolution is there. So the speed of the Ethernet has also get increases. Okay. But normally in our home and all, around 100 Mbps we will receive. Did you know how the speed will be? You check it, you may see that the speed around 100 Mbps. Okay. Now it's one of the very important question. While you are supposed to explain about the Ethernet, okay, I explain about the Ethernet, you are supposed to tell the Ethernet frame. Okay, what is IEEE 802.3? It is nothing but, we all know that we are following the standards, and used on the standards only we are supposed to creating the frame. Okay, we all know that this MAC frame will be the one of the primary work of the MAC layers. Okay, so this format you have to remember. How in microprocessor, how you are remembering the structure of accumulator, the structure of flag register, the structure of program status word you are learning now. Similarly, we have a standard, and according to the standard only, they will form this framing. This framing will be done in the MAC layer. So whether we are using a Ethernet now, they will use this standard IEEE 802.3. That is nothing but our Ethernet. This is our Ethernet standard frame. This is one of the, when you are explaining your Ethernet, you are supposed to draw this and you have to explain. Okay, and now you listen here. Preamble, SFD, destination address, source address, length, data and padding, CRC. Okay. What is CRC, ma? What is CRC?
Murthy, have you submitted, ma?
What is CRC? What is CRC?
Submitted in LMS? Okay. What experiment it is?
Kindly tell me. We have told you, and I have asked the problem also in that.
What is the transformer?
CRC is? No one is there to answer. What is CRC, ma?
Okay, you read
Hmm?
completely read it correctly. Huh? What is frequency?
Students, if you acknowledge only, I can understand that you people are listening.
Okay, what is frequency?
What is CRC? Full form of CRC. Unmute and you can say. You have the such options with you.
What is time period? What is time period?
Yeah, I'm getting over the chat. Yeah, Divya Darshini, correct. Cycle redundancy check. Why there is a question mark for that? Very good. Very good. Because that is one of the error control mechanism. We have seen that CRC. Okay. So when you see that, this all will be, this is my data and padding. This is only I will receive from my network layer. And in that network layer, this is physical layer header. They are saying that preamble and SFD is a physical layer header. The remaining destination, source address, length or type, and CRC. This will be appended with the header and tail will be appended, and then it is sent to the physical layer. Okay. Now you see that preamble. Preamble 7 bytes. We all know 1 byte equal to how many bits, ma? 1 byte equal to how many bits?
You submitted your paper.
1 byte equal to, we all know, 8 bits. Okay. So 7 bytes, na? 7 into 8, 56 bits. For preamble, SFD, start frame limiter, that is having 1 byte. Destination address. Okay. While we see about each and every field separately. Okay. In that preamble, we will see that it is mainly, it will be synchronized. Okay. And it is in the physical layer header only. This preamble and as SFD will be used. Okay.
TVR mode 551.
Now. Okay. Now when you see that SFD, start frame limiter, we said now. Here when you see to that, if the last 2 digit is 11 and alert that receiver and the next field is the destination address. In the SFD, if the last 2 digits are 11, it is alerting that frame that the next field it will comes to that will be destination address. So destination address will be something is I have to where I have to send my packet. That contains the destination address. If the destination address is not very sure, sometimes the source address will contain the destination address. Source address is where I'm going to send my packet. That address will be in the source address. Okay. The next one is length or type. That is according to the IEEE standard. Okay, Ethernet use this to upper layer protocol. Okay, using this MAC frame, and this will be which length and what will be the type will be decided by this 2 byte. Okay, data and padding that I told you. This data and padding will be the packet I will receive from the network layer. The maximum length will be 46 bytes. Sorry, minimum length will be, and if it is the maximum, the length will be 1500 bytes. Okay. And CRC always attached in the trailer part. There you can see that it is having a 4 bytes to check for the error detection. Okay. So I think this diagram is very, very important while you are telling about the IEEE 802.11. Okay. Now,
what are you searching for?
Okay, now you just see that first I told you that preamble and SFD mainly for the physical layer header. It is mainly used to synchronize the input frame. Okay, while I'm sending my signal. Okay, for example, this is my signal 100111. I have a clock signal also. This is my data and this is my signal. Okay, so for that this preamble is used. Because we all know that physical layer, the transmission, okay, even though it is a wired LAN, we are saying that, so we will transmit through the twisted pair cables, coaxial cables, or it may be through the it may be through the fiber opticals, so that we cannot able to predict that. So definitely my data should be synchronized with the clock signal. That is preamble purpose. SFD, the last 2 digit 11 indicates the destination will be the next bit. Okay, destination, source, length or type, and this is the data and padding. Okay.
2 3 of staircase wire.
Okay, that is all about this. Okay, now you listen this particular thing. Very simple. We can able to say for 46 bytes. Okay, 6 bytes, 6 bytes, 2 bytes, 46 bytes, and 4 bytes. So 6 plus 6, 12, 2, 14, 14 plus 46 around 64. So I have a 64 bytes. That is my minimum frame length. What is my maximum frame length? Na? 6 plus 6, 12 plus 12, 14 plus 4, 18. So 1500 plus 18. So the 1518 bytes. And this is 46 plus 64. So 64 bytes, or it may be 1580. This is my minimum frame length and this is my maximum frame length. You have to understand the length of the frame. Okay. Now the addressing part we are coming. Okay. Addressing part. How we will address the Ethernet work. Okay. We all know that in the wired LAN, the MAC layer, the network interface card is very, very important, where how the physical layer have the noting. You just see how many bytes are there. 1, 2, 3, 4, 5, 6. So totally 6 bytes are there. Okay. And while I am writing this bytes in bit, each byte having 8 bit, 1 byte equal to, we all know that 8 bits. How we will write? For example, 06 means how will we write? 0, 0, 0, 0, 0, 1, 1, 0. So totally 8 bits. So 1 byte equal to, we all know that it is 8 bit. So 6 bytes means 48 bits will be there. Okay. So you have to understand that this particular, whether it will transfer the bit unicast or multicast or broadcast. We always know that how a source address is always unicast. Okay. And while I want to send to the next station, it may be a multicast or broadcast, or it may be a unicast. We have to decide depending upon the number of bits. Very simple concept is around this.
Because it is,
you just kindly note down this. Okay. If it is the law 1 byte instruction, the last bit is 0, that is unicast. You just note down. The last bit is 0, unicast. If the last bit is 1, multicast. If all the bits are 1, the byte 1 contains all the bits are 1, that is always the broadcast. Okay, so we will see to the diagram what is unicast. I think while we are seeing about the types of computer network, we have seen that. But again, a small recap on this. Okay, now. Now you just see unicast. Unicast means point to point. It will transfer from one point to another point. That is unicast. Okay, broadcast, it will be transferred all the data packet in that IP segment. So it will transfer all the data packets in the IP. That is broadcast. Multicast means it will be that the point, one point to multiple points. That is multicast. So what you have understand from this now, you are understand that if it is 0, the 1 byte instruction unicast, 1 means multicast. If all the bytes are 1, that is broadcast. Okay. Now there is one small exercise for you.
What is energy?
0 unicast, 1 multicast, all bits are 1 broadcast. Okay, now you tell me, this will be the type of the destination address is given for you. Now you kindly identify it is a unicast or broadcast or multicast. Tell me one by one. You just take this 1 byte and this is byte 1, this is byte 1, and this is byte 1. So 4A, how will you write? You all know that 4A, how will you write? 0, 1, 0, 0, 1, 0, 1, 0. Am I correct or not? Use 8, 4 to 1 code. 8, 4, 2, 1 code I am writing. Okay. Then 47, how I will write? 0, 1, 0, 0, 0, 111. That is 7. Okay. And FF means what? All or 1. Now you tell me it is for which is unicast, which is broadcast, and which is multicast. Students, kindly put it in the chat. What I told you, unicast the byte 1 LSB must be 0. Multicast the byte 1 LSB should be 1. Broadcast the entire byte 1 should be 1. So tell me which is unicast, which is multicast, and which is broadcast. Students, put it over the chat, ma. Put it over the chat. Shikant, did you know the answer? Divya Darshini? Tell me the answer, ma. Tell me the answer. Students, are you there? Yeah, very good, Bhuvaneshwari. A is unicast. UNICAST. Good. A is unicast. Okay. What is B? The last bit is 1 means what? This is she said. What she said is correct. The last bit is 0 na unicast. Yeah. Which is broadcast, ma'am? Divya Darshini. B or C is broadcast. Yeah, very good. All the bits are 1 na, that is broadcast. Very good. Broadcast. If that LSB is 1 na, very good. It is a multicast. So that we can able to identify from this. Okay, very good, very good. All of you, very good. Okay, so
Sundar Singh, sir.
So you have to understand that the Ethernet work using this network interface called how from that physical address I can identify the type unicast, broadcast or multicast. Okay, that's it. Then category of standard. How we have seen depending on the speed now. This particular standard Ethernet categories depends on the cable. Okay, thick coaxial 10 base 5, 10 base 2, 10 base T, 10 base F. Okay, so that this two are thick. This is thick coaxial cable, thin coaxial cable, unshielded twisted pair cable, and fiber optics cable. Okay, this depends on the Ethernet, the material which is used in the Ethernet. Okay, and we all know that nowadays everything is transferred into the fiber optics. All the areas we have transferred the entire wired LAN into fiber optics. Okay. Okay, now
Attempt quiz, did you click?
okay. That encoding, I think, have you heard about this Manchester encoding in the twisted pair of cable? Na? I told you, na, the clock and data should be always synchronized while I'm sending. So the Manchester encoding means you just see this. My data is 1. Okay, my data is 1. Okay, if my data is 0. Okay. And you all know that what is the difference in sending data 1 and data 0 means according to IEEE 802.3, that is I told you Ethernet standard, if logic is 0 means the transition level from 0 to 1, it will transmit from 0 to 1. Then I can understand the bit will be transferred as a 0. Okay, if it is logic 1 means the transition will goes from 1 to 0. Okay, or 0 to 1. This all depends on the data. So depending on the data, and you all know this is my data now, my clock signal will be synchronized with this data. Okay, when I am doing this is, I think this is not needed in this particular topic. Why I am saying now the Manchester, it's a standard we are following how my data should be synchronized with the clock and how it is transmitted. We all know that the physical transmission may be through air I can and to convey that is air is nothing but radio signals I can transmit, and through the wired medium I am transmitting, and that you all know that while I am sending how my packet is sending and all with the data logic 0 now it is indicated from 0 to 1 transition, logic level 1 now it is will be transmitted from 1 to 0 at the center. That's why they told you it is at the center. At the center it will go 1 to 0 and 0 to 1. It's clear? Okay, now we will go with the type.
Cycle, what experiment did you do? Unmute yourself.
Okay. Now you all, we will see about 10 base 5. Okay. 10 base 5, you all see to that. This all about the kind of cable and kind of length will be decided. That's it. Okay. 10 base 5 means you all understand this 10 stands for 10 Mbps. Okay. Okay. 10 Mbps speed, and 5 means it's a 500 meter, and a thick cable will be used. Okay. And you all know that this maximum thick coaxial cable length will be around 500 meter. Okay. So you all know that if I can connect here, and this length will be maximum of 50 meter. So you all know that in the wired LAN, I can go always with my CSMA CD. Okay. Okay. Carrier sensing multiple access with collision detection. Why? Because now in the wired LAN we have an advantage. I think ma'am have especially told you the point. The energy level will be E1 equal to E2. That means I can understand that E1 means is the sending signal and E2 is a receiving signal. If both the energy level are equal, then it will be it will be sent without any collision. And one more thing, when I'm seeing that my energy level is greater in the second case, there we can understand that it is a jamming signal. Okay, so that you have to understand. So here we are all using wireless LAN only. We have a go with the CSMA CA problem, because in wireless LAN there will be no much difference on the energy level of the signals. Okay, so here when you see to that, here 10 base 5, you all see thick coaxial cable with the maximum length of 500 meter, and the speed is 10 Mbps. Okay.
Now it's something.
The next one is 10 base 2 implementation. 10 base 2 implementation. In the 10 base 2 implementation, the speed is 10 Mbps. Okay, and the length will be around thin coaxial cable. Now the length is increases to maximum of 185 meter. Okay, and you all know the T connections also available. Wherever I am connecting my Ethernet cable, I have a T connections also there. Okay, so it's much cheaper than the previous one. Okay, and thin coaxial is very flexible. I think in the lab also, I think we were using. If I take it, I think. Okay, I think you can able to see this in camera. So this Ethernet cable, it's all you've seen. This is a thin coaxial cable, and you all know that it's a fiber optics only. While you see to that, it's all flexible. It's not like more thick. So, and it is easy to take the taps. That's why it's a thin, and we all using Ethernet cable on purpose. 10 base T. The next one is 10 base T. Again, the speed is same thing, 10 Mbps only, but T we use as the twisted pair. Okay, maximum this twisted pair will be 100 meter. To minimize the effect, attenuation problem is in the attenuation means you all know the signal receiving will be attenuation stopping the signal. That problem is in the coaxial cable, that is recovered in the twisted pair cable, that is UTP. Okay, unshielded twisted pair cable is there. So there the particular 10 base T problem is rectified. Okay, the speed is around 10 Mbps, and T stands for twisted pair. Okay, and the maximum length of the cable is 100 meter, and it will minimize the effect of attenuation. That problem is rectified in this particular case. Okay. Okay, so I think the next one is what? Fiber. 10 base F problem. 10 base F. Fiber. Okay, so fiber, while I'm going with that 10 Mbps, and you all know again we use the UTP only. That's why while I'm showing this Ethernet cable, we are using the fibers only. But you all understand that in the 10 base F, 2 fiber optic cables will be there, and the maximum length of this twisted cable is around 2000 meter. Okay, and I told you the maximum the transferring of data nowadays it will become into the fiber. Okay, so while I'm seeing about all this 4 category, 10 base 5, 10 base 2, 10 base T, 10 base F. Okay, and first one is thick coaxial, thin coaxial, and when you see that it is a unshielded twisted pair, and this is a fiber optic cable. And while we are seeing about the distance, while we are seeing about the distance, here while we see to that about 500 meter, and while you see to that it's a 185 meter, and see to that 100 meter, and see to that 2000 meter, and when you see to that all that will be same speed. Okay, so 500 meter, 185 meter, 100 meter, and 2000 meter. The attenuation problem is rectified in the UTP. Okay, unshielded twisted pair, but all that speed will be 10. Okay, 10 Mbps. And you all know the baseband will be always digital one. Okay, this is all about wired LAN only we are discussing. Then changes in standard wired Ethernet. We have a bridged Ethernet, switched Ethernet, full duplex Ethernet. Okay, first one we seen depending on the speed. Okay, from 10 Mbps to 10 gigabit per second. Then we have seen depending on the cable we used, 10 base 5, 10 base 2, 10 base T, 10 base F. That all depending on the cable material used. Now the next one is changes in the Ethernet, how it is transferring the data. Bridged data, bridged Ethernet, switched Ethernet, full duplex Ethernet. We have a 3 types. Bridged Ethernet. Okay, the bridged Ethernet means you have to understand that you have to see to that it always sharing the bandwidth. Okay, while we see that in this particular all this switched or whatever may be, the total capacity is, for example, if it is 10 Mbps now, while it is transferring, it will be shared divided by 2, 5 Mbps. So first 5 Mbps will be sent, the next 5 Mbps will be sent over the period of time. So that is always we will do sharing the bandwidth will be done in the Ethernet network. Okay. Actually, the next one, sharing the bandwidth, we will see one by one type. Okay. Now, network with and without bandwidth. Okay. So now you see, there is no bridging. Here nearly 6 systems, and here nearly 6 systems. So totally 12 systems. I have connected my Ethernet cable. But when I am seeing that my bridges without bridging, I am giving 10 Mbps speed is there. Then automatically it is shared by 12 computers now. 10 Mbps by 12. That's why sharing the bandwidth. So automatically what happened? 10 by 12. That much of speed only each system will be done. But when I am done the bridging here 10 Mbps and here 10 Mbps now, here 10 Mbps by 6 and here 10 Mbps by 6. And you all know that by bandwidth, the network is also independent and the speed is also get increases. So the more advantages with bridging only. Without bridging, the speed will be less, as well as the network is also not independent. That's why we always go with network with bridging and we will share the bandwidth. Okay. Then you all seen that collision domain. Okay, we all know that we are always following the CSA collision detection and all. So the same thing I'm saying 10 by 12. But when I'm going with bridging this kind of domain, again when you see here, this will become 10 by 3, 10 by 3 and 10 by 3. So comparatively, the speed and the sharing will be done with bridging. Okay. So here I can check the collision domain with and without bridging, because here I have to look up all this 12 and we are domain wise 3, 3, 3. So this type of bridging always have an advantage over without bridging. Okay. So this is switched Ethernet, and we all know, sir, that the bridged LAN is extended to each switched LAN. Each are considered as a domain. So if there are n multi-port is there, with n port is there, n domain will be there, that will be connected to the switched Ethernet. Okay. This is full duplex. Okay, whatever we see in the 10^5 and 10^2 are half duplex. Whether it will do both send and transmit, but it will be done one at a time. But when you go with full duplex mode, it will increase the capacity from each domain from 10 to 20 Mbps. That's only we have seen. No need for CSMA and CD. That is not needed in the full duplex switched Ethernet. Okay, it's one simple example how it will transmit as well as it will be done. Okay, and each and everyone will check for this collision. So full switched network, that collision detection is not required. Okay, because we have a send and transmit, we have a full duplex control over that. Okay, so these are the various fast Ethernet only now we are using, and we are using with the switched Ethernet. Okay, IEEE, the standard is 802.3. Okay, then fast Ethernet is standard with it can transmit data 10 times faster at a rate of 100 Mbps. That's why I told you here. Now the speed will be very high in the fast Ethernet. Okay. Okay. So I think the Ethernet get over. Whatever we have seen till here will be about Ethernet. So entire Ethernet we have completed. You just see this. If you ask about Ethernet, you have to tell depending on the speed. There are 4 types, and that Ethernet frame IEEE 802.3 MAC frame you have to explain it. Addressing you have to explain, and then categories of standard Ethernet depending on the implementation. Coaxial, twisted pair, fiber cable, we have to explain it. And then we have to changes in the standard, how the internet have become more faster. Bridged Ethernet, we have to go. Without bridging, the speed will be less, as well as the network is not independent. When you go with bridged Ethernet and switched Ethernet, full duplex Ethernet. So this is bridged Ethernet, and this is switched Ethernet. For each and every switch is connected to n switches are there, n domain we will connect, and automatically the bridged LAN, comparing the bridged LAN is extended to switched LAN. Much more it will be close to that only. But when you go with full duplex, it is entirely different, where we go with the full duplex method. So no need of that CSMA CD we need for wireless LAN. Wired LAN we need, but in this particularly full duplex switched Ethernet, we don't need of the CSMA CD, and there we have a send and receive. We have a separate. It will transmit full duplex mode with the increase in speed capacity. And while we move on to this, nowadays we are all using the full duplex switched fast Ethernet that will be more faster than comparing with the other Ethernet. Okay. Next one is wireless LAN. Have you understand any doubt in this topic? Any doubt? Any doubt in this topic, ma? Students, any doubt in this topic? Do you know the answer to this? In wired LAN, we have any doubt? Wired LAN, we have discussed about the Ethernet. Okay. Now we are moving on to wireless LAN. Any doubt in wired LAN? Kindly let me know, ma'am. Students, kindly acknowledge. Alina, you want to say something?
See the question there.
No doubt, ma'am. Okay. The next one is wireless LAN. Wireless LAN, we have 2 types. One is IEEE 802.11. Wireless IEEE 802.11 and Wi-Fi. Both are in wireless LAN. Okay. Now I think we will see to that in wireless LAN. We will see what are the 2 kind of services there. One is BSS and another one is ESS. Okay. BSS means basic service set, and ESS means extended service set. In the wireless LAN, we are going to see IEEE 802.1.1. That is our Wi-Fi. That is our Wi-Fi. And the next one is Bluetooth. Before entering into that, we will see BSS and ESS first. Okay. BSS means without an AP, that is ad hoc. Ad hoc means it's a temporary local area network, LAN, that is ad hoc network. That doesn't have any access point. That doesn't have any access point. Okay, that is we used to say ad hoc network. BSS with a multiple AP, that is infrastructure. Okay, infrastructure. BSS with an AP is said to be as a infrastructure. Okay. Now I will explain you how this BSS and ESS is used in the day-to-day applications. Okay, now you take this example. If my two wired principles, we all know that we are communicating between the two things. Okay, if it is a wireless, how I will transfer my data from one system to another system now? Through the air, it is nothing but through radio signal, I will transfer my data. Now, if I want to share, more devices, okay, how you have at that point is nothing but your access point. That is nothing but your Wi-Fi. Okay, in that Wi-Fi, if I want to share to multiple systems, one laptop, one PC, one smartphone, that I want to that we are all using in our home, we are all using Wi-Fi. So obviously we have a shared bandwidth. So 100 Mbps per speed it is getting now, 100 Mbps by 4, 25 Mbps. Okay, so each and every channel will half duplex. Okay, we all know it will do send or receive, but both will happen, but both will not happen at a time. Whether it will do send or receive. And we all know that CSMA CA, wired LAN is nothing but the best example is Ethernet. In the wired LAN, Ethernet, we are all using CSMA CD, wired LAN. Note down this. And wireless LAN, we are all using CSMA CA, collision avoidance. Okay, we will prevent the collision. Okay, here collision will be detected only, but here collision will be prevented. So that you have to understand this in hub also we will transfer. So one mode is through radio signals, the transfer. If we have a multiple, we have an access point to connect with the various devices. Okay, now I will explain you the BSS, how BSS is working. What is BSS now? Listen, basic service set. Okay, basic service set means, for example, I have access point, I am communicating with the two laptops that we all know, we are all using the wireless LAN. This is the symbol. Okay, if I want to identify in the MAC address, we used to say the word BSS identifier. Or else, as a human being, we have to understand, we will use service set identifier. For example, your Wi-Fi name will be your name. Okay, when you take our college Wi-Fi, it will be in the Satyabama. Okay, Satyabama EEE, Satyabama ENC. That is a logical name which our human being can identify. That is service set identifier. BSS identifier means the AP access points on the radio MAC address. So whatever may be, this access point have an authority to accept or decline the request. If any of my range, if any new systems enter into that, if I want to access this point, my access point have an authority to decline or accept. Okay, this is BSS. BSS means what? Basic service set. One access point will be there, and through one access point, I can connect the multiple devices. So my access point have a capability to accept or reject. But in our human being terminology, we used to say it's a service set identifier. But when you come into the MAC address, we used to say basic service set identifier. Okay. Now one problem in this BSS. Okay. That is overcome in the ESS. ESS means what, ma? Extended service set. For example, when you take in our entire building or hospital, or it may be a restaurant, they want to, it's a large building, we all know that we have a Wi-Fi range. It will be used for one room or home for that purpose. If it is in the entire building or that I want to do that now, I cannot go with basic service set. I have to go with extended service set, ESS. ESS means we have a multiple access point. That is ESS. What is ESS now? I will take you this diagram. I will take you this diagram. This is my ESS. What is the ESS now? You just say whether the coverage is in the limitation. In BSS, the limitations coverage is there. But here, when you go with the, I want to do for building and all, that is also the limitation coverage is there. But number of access point we were using. Okay. Now you see, I'm using two Wi-Fi. One is employee Wi-Fi and another one is guest Wi-Fi. Okay. There I have here one AP and here one AP. So using this trunk, I can create the multiple APs. Okay, that is we used to say distribution system. So, for example, if my system is in this particular range, this AP will connect with this. When I am connecting this, any one of the AP will connect. When I am in this range, automatically this will connect. So that we use say extended service. I think when I am moving from one area to another area, I have a distributed service. That is one of the advantage in the wireless LAN. So we have a basic service set, or we can go with multiple access point where I can go with the extended service set. Even it is will be in the coverage where I can use it for my hotels or restaurants or house or research building, whatever may be. I can go with the schools. We can go with this extended service set. Basic service set with one access point, extended service set with multiple access point. Yes. Yes, are you listening? Okay. I think one thing I will do this. This is I have taught you the basic thing. I will go with you just see that CSMA CA. You just see the 2 is there, automatically the collision is occurring, then automatically it is discarded. Okay, that's why we are going for collision avoidance method. In that we have two problems: hidden station problem and exposed station problem. Why? Because now while I'm explaining the collision avoidance in wireless LAN, you have to understand these two problems very well. Okay. Hidden station problem. Okay. What is hidden station problem? Now you just see. Have you seen this? How that it will be received and it will there collision is occurred, then automatically it will be discarded. Okay. So CSM is we always go with CA. Hidden station problem. You just see this hidden station problem. What is the use of RTS and CTS? Okay. Range of B, range of C. B covers B and A. C covers C and A. But B and C are hidden from each other. Am I correct or not? In the range of
Yes,
B,
ma'am.
A is there. In the range of C, A is there. Okay. But B and C are hidden from each other. Now we will see how it is working, how the hidden station problem is occurring. You just see here, RTS, request to send and clear to send. Okay, now I am sending the B to A. Okay, and automatically in the particular range of A, it will receive the RTS from B. Then the A is range in both B and C. B and C. So both it is sending what message, ma? Clear to send, clear to send. So automatically station C station C will understand that now the A is communicating to some other. At that time, it won't communicate with C. Because once it receives the CTS commands that someone has requested A and A is communicating with that particular channel B, so C won't communicate with A. This is the hidden station problem. Okay, so that is the purpose of RTS and CTS. It's like a handshaking signal. In a microprocessor, you have studied hold HLDA. First, it will ask the request whether I can communicate with the processor. If microprocessor acknowledges for that, automatically my peripheral will communicate. Now, similarly here also, B is in the A is in the range of B as well as C. So once it receives the request to send command from B, then automatically whatever it sends the CTS will send to both B and C, but C will understand automatically it is communicating with another channel. It won't communicate at that period. Okay, this is hidden station problem. Okay, the next one is okay, the CTS frame in CSMA-CA, handshake can prevent collision from a hidden station. You all know that the CTS play a vital role. The CTS clear to send. From this signal, we can understand that automatically the collision avoidance, okay, a handshake can prevent collision from a hidden station. This particular frame can understand, okay, because it is communicating with some channel. So I should not send any signal to the A. From C to A, the communication will not happen. This is the working. Okay. Now we will go with exposed station problem. Okay. I will complete after this exposed station problem. You just see here in this diagram, range of B. B is exposed to range of first we see range of B alone is that, range of A, B, A, C is that, range of C, A, C, D is that, range of B alone, okay, range of A, ABC, range of C, ACD. Okay, now I think I will go with the RTS CTS concept, then you will understand. Now that range of B. Now my A and B are communicating. My A and B are communicating. Okay. While I'm doing communication with A and B, whether C and D can communicate now, it cannot be communicated. It cannot be communicated. How we can see now? Once it started communicating, B and A should communicate, A and C should communicate, but C and D should not communicate. That is the exposed station problem. What is that now? First, I am sending RTS. Okay, and while I am sending that RTS, okay, that acknowledge CTS signal will be received. So what happened now? The A will communicate with both the B channel, B station and C station. Once I want to communicate with D, again the C coverage area, A and D is that. Again it is sending RTS now. Already it is sending the data A to C now. Then automatically, even though I received a CTS command from the D, here the collision will occur. So this is exposed station problem. Okay, so while we see to that how this RTS and CTS along with the CA problem, CSMA CA problem will be done in this wireless LAN. We will see in the next offline class. Is clear, ma'am? Yes. Okay, we have two problems. Yes, one is exposed hidden station problem. Okay, the next one is exposed station problem. These two problems. Okay, there we go with CSMA CA, network allocation vector will be done. Okay, now I will.